In this video, we will learn how to find out the profit maximizing output of a pure monopoly firm given the cost and price functions. The question is, short-run cost and demand functions for a monopoly are given as cost function is 50 plus 20q plus q square, and inverse demand function is, that is, p is equal to 500 minus 5q. Q denotes the output, p is the price, c denotes the total cost. We have to find out the profit maximizing output of the pure monopoly firm. Okay, so we are being given the inverse demand function is p is equal to 500 minus 5q. Okay, this is our inverse demand function. To find out the profit maximizing condition, we require to equate the marginal revenue with the marginal cost. Okay, this condition must hold. So that means we have to find out the marginal revenue and marginal cost. To find out the marginal revenue, first we should know what is total revenue. Total revenue is simply price into output. So it will be equal to P. In place of P, we have 500, 500 minus 5Q. To this we multiply by Q. That is our total revenue function. And let's write it here. Total revenue function will be equal to 500 Q minus 5Q square, and marginal revenue is simply the derivative of total revenue function with respect to output. That means differentiating this function with respect to q, derivative of q is 1, so we are left with 500. Derivative of q square is 2q, so 2 into 5 is 10q. There is simply x raised power n, its derivative is n, x raised power n minus 1. We are here, we have q raised power 2, so its derivative is 2 becomes coefficient and exponent is subtracted by 1, that gives us 2q here. Okay, so this 2 gets multiplied with this 5, so it becomes 10 here. So our marginal revenue, marginal revenue came out to be 500 minus 10q. Okay, similarly we need to find out the marginal cost. So to find out the marginal cost, as we know, and let me write it here. So to find out the marginal cost, we should know what is our cost function, that is 50 plus 20q plus q square. Marginal cost is simply the derivative of cost function with respect to output. Derivative of a constant is 0, derivative of q is here 1, so we are left with 20, and derivative of q square is twice q. Okay, so we are done with marginal cost is 20 plus 2q. Okay, we know profit maximizing condition is that marginal revenue should be equal to marginal cost. So this is our marginal revenue, and let's write it here, 500 minus 10q, and it should be equal to the marginal cost, which is 20 plus 2q, 20 plus 2q, solving for q, so transposing this here, so 10q plus 2q is 12q. 12q is equal to 500 minus 20 is 480, I guess. Dividing both sides by 12, here also and here also with 12, so this 12 and 12 gets cancelled, so 12 ones are 12 fours are, so we will get q is equal to 40. That means profit maximizing output will be equal to 40. Now if I want to show it on the graph, let's be specific here. So we have quantity on the horizontal axis and price on the vertical axis. Okay, this is the demand function, that is average revenue function, that is the inverse demand function, this function. It is slow, rather it is intercept is here 500. From this we find out the marginal revenue function, that is MR function. From cost function we got the marginal cost function, that is 20 plus 2q, and let's draw it here. Let us say this is 20 here, 20. So profit maximizing condition was that marginal revenue and marginal cost functions should intersect with each other, and they intersect at this point at an output level of 40. Okay, and To find out the profit maximizing price, we can also find out the profit maximizing price. Simply plug P, the optimal value of output into the inverse demand function. That is, our profit maximizing price will be equal to, in place of Q, we have 40. Okay, so price will be equal to 500 minus 4 5s are, so price will be equal to, I guess it is 300 if I have done the calculation right. So corresponding to this, we have a price of 300. Okay, I hope I make myself clear in this video. Thank you.